Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Farham bin Yusuf dan saya akan terangkan tentang cryptology in number theory. Cryptology is process transferring information securely in a way that no unwanted third party will able to understand the message. Cryptology is the art and science of making and breaking code and cipher. Cryptology includes the concept prime number, greatest common divisor, modular arithmetic, and division algorithm. First, we see a prime number. A positive integer is called a prime number if it is divisible only by 1 and itself. Every positive integer is uniquely a product of prime number. For example, we will see that factoring a number into its prime factor is extremely difficult and play an important in cryptology. We call that infinity many prime number. Next, we move to the greatest common divisor. Both A and B have factorization into a product of prime number. A and B has to be a positive integer. We would like to see a way to measure how much the factorization overlap. Example, GCD A B equal to 1. We say that A and B is relative prime. This terminology comes from the fact we have no common proper divisor other than 1. Giving example, if P is prime, then we know that GCD AP is a divisor of P for any A. Thus, we have GCD AP equal to 1 OP. As we mentioned above, factorization is very difficult process. So we have to above proof show how to construct the greatest common divisor. The division algorithm. Two positive integer m less than and equal to n. We can do a long division to find the quotient n and a remainder of r, so that we can write n over m is equal q with remainder r. Reversing this procedure show that n equal to q times m plus r. Moreover, the long division makes sure that r less than n, so that q and r we find are unique. Lastly, we move to modular arithmetic. Fix a positive integer n. We can say the integer a and b are congruous modular n if n divide a minus b. In this case, we write a congruous b mod n. We now state an A theorem which explains how usually arithmetic we have on modular n. We move to cryptology in real life. Cryptography in everyday life contain a range of situations where we use cryptography facility to provision of a secure service, such that cash withdrawal from the ATM, play TV, email and file storage using pretty good privacy, PGP, freeware, secure web browsing, and use a GSM mobile phone.
Okay, next I will explain about the Caesar cipher. So, Caesar cipher is one of the earliest known and simplest cipher. It's a type of substitution cipher. So, the method is also known as Caesar's cipher, Caesar's code, and also called as shift cipher. So, basically, it involves two main processes, which is the encryption and also the decryption. So, for the encryption, encryption is the process of translating the plain text data or the plain text into something that appears to be random and meaningless, or the ciphertext. And the decryption is the process of converting the ciphertext back to the plain text. The ciphertext is what the enemy or hacker would see instead of the true or the actual message. So the encryption process can be represented using modular arithmetic by first transforming the letters into numbers according to the scheme A equal to 0, B equal to 1, and up to Z equal to 25. Each letter in the plain text is shifted a certain number of places down the alphabet. So for the very simple example, if we are using shift of 1, A would be replaced by letter B, and B would become C, and so on. So this will produce what we call the ciphertext. So in this way, a message that initially was readable end up in the form that cannot be understood. Okay, next is the encryption process. So the encryption of a letter X can be expressed by ENX equal to X plus N mode 26, where X is the plain text, N is the number of shifts, and 26 represents the letters in English alphabet. For the decryption process, the ciphertext can be decrypted by applying the same number of shifts in the opposite direction or the inverse direction. So it can be expressed by DNX equal to X minus N mode 26, where X is the ciphertext, N is the number of shifts, and 26 represent the letters in alphabet.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Walif bin ID. Okay, I will explain about example of the Caesar cipher. Okay, the encryption and decryption can be represented using modular arithmetic, which is encryption ENX equal to X plus N mod 26, where X is encryption of letter and N is shift. Decryption DNX equal to X minus N mod 26, where X is encryption of letter and N is a shift. Okay, example for encryption: suppose that alif password at work must be a series of 4 letters that do not form a word. Use a Caesar cipher with a shift length of 4 to encrypt the plain text mate anytime he need to retrieve the password. Encrypt mate to determine his password. Okay, we use the equation. I use the formula ENX equal to X plus N modulo 26, where N equal to 4. For word math, for M equal to 12, ENM equal to 16, where 16 is representative number of Q, so ciphertext for M is Q. For A equal to 0, E and A equal to 4, where 4 is representative number of Q, so ciphertext for A is E. For T equal to 19, E and T equal to 23, where 23 is representative number of X, so ciphertext for T is X. For hash equal to 7, E and hash equal to 11. 11 is representative number of L, so ciphertext for hash is L. We combine all the ciphertext, therefore alif password is QEXL. Okay, example for decryption. Decrypt the ciphertext WJIRN. The key is a shift length of 5 using Caesar cipher. Use the formula DNX equal to X minus N mod 26, where N is equal to 5. The word used is WJIRN. For W, W is equal to 22 and dnW is equal to 17. 17 is representative number of R, so ciphertext for W is R. For J equal to 9 and D and J equal to 4. 4 is representative number of J, so ciphertext for J is E. For I equal to 8, D and I equal to 3. 3 is representative number of D, so ciphertext for I is D. For R equal to 17. So D and R equal to 12. 12 is representative number of M, so ciphertext for R is N. For N equal to 30. Dn equal to 8. 8 is representative number of I, so ciphertext for N is I. Therefore, the decrypt of ciphertext of WJIRN with a shift length of 5 is REDMI. That's all. Thank you.
Okay, next I will explain about the affine cipher. So the affine cipher is a type of monoalphabetic substitution cipher where each letter in an alphabet is mapped to its numeric equivalent. So it also involving two main processes, which is the encryption and also the decryption process. It is encrypted using a simple mathematical function and converted back to a letter. So in this cipher, the letters of an alphabet of a size m are first mapped to the integer in the range of 0 up to m-1. It then used modular arithmetic to transform the integer that each plain text letter correspond to into another integer that correspond to a ciphertext letter. Okay, next the encryption process of the affine cipher. So the first step in the encryption process is to transform each of the letters in the plain text alphabet to the corresponding integer in the range of 0 up to m-1. So the encryption process for each letter is given by EX equal to AX plus B mod M, where M is the size of the alphabet and A and B are the keys of the cipher. So note that the value of A must be chosen such that A and M are relatively prime. In other words, we have to ensure that the GCD of A and N equal to 1. Okay, for the decryption process, in deciphering the ciphertext, we must perform the opposite or inverse functions on the ciphertext to retrieve the plain text. Once again, the first step is to convert each of the ciphertext letters into their integer values. So the process of deciphering the ciphertext can be expressed by dx equal to A inverse times x minus b mod m, where modulus m is the size of the alphabet, A and B are the keys of the cipher, and A inverse is the modular multiplicative inverse of a modulo m.
Now let us look into an example of encrypt for affine cipher. So first, we need to convert the letter that we want to encrypt. Like for this example, we use I love math. Okay, we use this 9 letter. We want to convert it. We want to encrypt it with affine cipher. So we need to convert it into number first. So the number is for A is 0, B for 1, and so on. So now we convert the word into the number, like I is 8, L is 11, and then so on. So after we convert it into number, so we need to use the formula to change it into to encrypt it. So now we take A as 5, B as 15. So we will have if we want to encrypt the S, we will have E for the S is concurrent to 5S plus 15 mod 26. So we try to encrypt it, we try to transfer the number. So we will get 3 for 8, 18 for 11, 7 for 14, and so on. So after we encrypt it, we need to convert the number back into the letter. So just follow the A equal to 0, A equal to 0, B equal to 1, and so on. So we will get DSHQ JSPGY. So this is the code. This is the code that we encrypt. This is the result that we encrypt. So for the next example, we will look into the example of decrypt for the Affine cipher. So let us take the example from A. So we know that A is equal to 5, B is equal to 15. So we need to find the inverse of A. So to find the inverse of A, we need to find the number that is multiple with A, which is 5. This is congruent to 1 mod 26. For 5, the inverse will be 21, because 21 times 5 will congruent to 105. That incongruent to 1 to the mod of 26. So now we find the inverse of A is equal to 21. We just insert it, we just substitute it into the formula. So D for the S is congruent to A negative to the power negative 1 inverse A inverse bracket S minus B mod M. So we just substitute. So we will get DS congruent to 21. So bracket of S minus 15 mod 26. So now we need to decrypt the code that we get. Like now for our example is the DSHQ JSPGY. So we need to decrypt first. Same we encrypt. We need to transfer it into number first. Okay, after transferring into number, we just use the formula we get just now to transfer the number one by one. So we will get like 3 equal to 8, 18 equal to 11, 7 equal to 14, and so on. And after that, we just take the number that we get. After we decrypt, we just convert it back into the letter. So we will get ILOVEMATH. I love math. So this is how we encrypt and decrypt with the Affine cipher. Thank you.